All right, let's jump right in. Every time you stream a movie, get one of those scarily accurate product recommendations, or even just check a weather app, there's this invisible force humming away in the background. And no, it's not magic. It's data engineering. In this explainer, we're going to pull back the curtain on this incredible discipline that brings order to the absolute chaos of our digital world.
You know, to really get a handle on data engineering, you kind of have to go back to the term that started it all, big data. And honestly, nobody, and I mean nobody, captured the initial hype and confusion better than behavioral economist Dan Ariely. He had this amazing quote: "Big data is like teenage sex. Everyone talks about it, nobody really knows how to do it, everyone thinks everyone else is doing it, so everyone claims they are doing it." And man, does that just perfectly nail the frenzy that took over the tech world.
And look at this. This graph shows you exactly what he was talking about. You can see right here on Google Trends how interest in the term big data just exploded around 2011. It was the buzzword. But look what happens next. You see how it's kind of plateaued and even dipped? That's not because data suddenly got smaller. Oh no. It's because the industry started to grow up, moving past the hype and getting down to the real, practical work of actually engineering all that data.
Okay, so let's move past the buzzword. The real challenge, the thing that created this perfect storm of complexity, wasn't just the data was getting big. The very nature of the data itself was changing in some really dramatic ways.
People usually break this down into what they call the 3 V's. First, you've got volume. We're talking just a staggering amount of data. Think of every single Netflix view, ever. Then there's velocity. That's the speed. Imagine the relentless stream of clicks and likes hitting social media every single second. But maybe the trickiest one was variety. Data was no longer just in neat little tables. It was coming from everywhere, in every shape and size imaginable. Messy tweets, photos, videos, sensor readings. It was, in a word, chaos.
And into this data chaos steps our hero, the data engineer. You can think of them as the architect, the plumber, and the traffic controller for all of an organization's data. They're the ones who build the systems that tame this crazy flood and actually make it useful.
Now, what's so fascinating about this role is that it's not just about being a whiz at coding. The truly great data engineers are like a human Swiss Army knife of skills. They have to be master communicators, able to translate what the business needs into a technical plan. They're constantly balancing performance against cost, trying to get the most value. And maybe most importantly, because the technology changes at lightning speed, they have to be absolutely relentless learners, always keeping up with what's next.
So how do they actually do it? Well, data engineers don't just dump data into a big, messy pile. They meticulously guide it through a very structured process, a kind of journey we call the data engineering lifecycle. This is how they turn raw, messy stuff into a refined, super valuable asset.
Let's walk through this journey with a super simple example, okay? Your online shopping cart. Generation, that's you, clicking add to cart. Ingestion is the system grabbing that click event. Storage is where that event gets put into a massive database, a data lake. But here's where the real magic happens: transformation. That's where engineers clean up millions of those clicks, link them with user data, and figure out stuff like items most frequently bought together. And finally, serving is when that powerful insight fuels the "you might also like" recommendations you see on the website. See?
But wait, the story doesn't always end there. There's this really powerful modern idea called reverse ETL. So imagine after all that analysis, we figure out that a certain customer is very likely to cancel their subscription. Instead of that insight just sitting on a dashboard somewhere, reverse ETL pushes it back into the company's marketing tool. This automatically adds that customer to a special "please don't leave us" campaign. You see what happened? It closes the loop. It takes an insight that was just sitting there and turns it into an immediate, real-world action.
So to build all this stuff, these pipelines, this whole data factory, engineers have a massive toolkit to choose from. But it really all starts with a couple of huge architectural decisions about where and how this whole operation is going to be built.
The first big fork in the road is on-premise versus the cloud. The old way was companies bought and managed all their own servers in their own data centers. And then the cloud came along and just changed the entire game. For data engineering, this was a revolution. It meant you could suddenly fire up a massive cluster of computers for a huge job that maybe only runs for an hour and then shut it all down. And you only pay for that 1 hour. Think about that. You don't have to buy a mountain of servers that just sit there gathering dust 99% of the time. This flexibility is why almost everyone has moved to the cloud.
The next big choice is picking the right database for the job. You know, you wouldn't use a screwdriver to hammer in a nail. It's the same idea here.
A relational database is like a super strict spreadsheet with lots of rules. It's perfect for things like financial transactions where everything has to be perfectly precise. A document database is way more flexible, kind of like a digital filing cabinet. Great for things like user profiles, where you might need to add new information over time. And then you have graph databases, which are built for one special thing: understanding really complex, interconnected relationships.
And this gives you a perfect idea of what a graph database is all about. Instead of rows and columns, you have nodes, like these people here, and edges, which are the lines connecting them that define their relationship. You can see right away why this would be perfect for mapping out a social network or a complicated supply chain, or really any system where the connections are the most important part of the story.
Okay, so building these incredibly powerful systems is one thing, but with this massive river of data flowing through a company comes huge responsibility. You can't just open the floodgates and hope for the best. You need rules, you need security, and you need a serious plan for governance.
This is where data governance comes in. It's basically the official rulebook that makes sure data is treated like the critical business asset it is. It's the framework that answers all the tough questions, like who is allowed to see customer emails? Can a marketing intern delete financial records? No way. How do we prove to our auditors that this sales number is legit? That's all data governance. Because let's be honest, all the governance in the world doesn't mean a thing if the data itself is garbage. Two of the absolute pillars of data quality are accuracy, is this information actually correct? And completeness, are we missing critical pieces of the puzzle? Without those, any analysis you do is built on a foundation of sand, and it's all just going to collapse.
And this all leads to a really simple, but honestly a profoundly powerful idea in security: the principle of least privilege. It means exactly what it sounds like. A user should have access to the exact data they need to do their job and absolutely nothing more. This one simple principle can stop countless data leaks and security breaches before they even start.
So, after all this work, the life cycle, the tools, the governance, what's the big payoff? Why does all of this matter so much in the real world? You know, this quote really nails it. Just collecting data is totally pointless. It's inert. It's just sitting there. The entire goal of data engineering is to transform that data from a useless, inert pile into something that can be consumed, queried, and ultimately used to make smarter decisions. It's all about turning potential into practice.
Because the alternative, well, it's kind of terrifying. Bad data is a silent killer inside a business. When the engineering is done poorly, faulty numbers can sit in dashboards and reports for months, leading smart people to make terrible, misinformed decisions. It completely destroys trust and can have catastrophic results. Which really drives home the point, right? Good data engineering isn't some nice-to-have luxury, it is the absolute foundation of any modern, intelligent business.
And that leaves us with one last, really big thought. Data engineers aren't just building tech systems, they are literally the architects of our digital foundations. So as they build the world we all increasingly run on, the challenge isn't just about making things bigger or faster anymore. The real question we have to ask is, how do we make sure these systems are built to be ethical, private, and secure right from the very beginning, by design?